Today we're going to be talking about section 3 of our textbook, which covers trigonometric integrals. Really what it is today we're going to be dealing with integrals that have to do all with trigonometry. We're going to be using either identities or these rules that I will provide for you, and then identities to help you solve those integrals. Cool? We're going to divide this up into sections. First we're going to talk about sine and cosine, and then we'll move on and talk about cosecant, cotangent, secant, and tangent, etc., etc. Cool? So we'll start out with the more basic and the more simple ones to deal with, which is sine and cosine. So there are three scenarios you're going to deal with here. I've already written them here, so if you're watching the video, just go ahead and pause the video, write down the rules. And if you're in class, I'm going to do the same thing. I'm going to pause the video, write down the rules. We'll use the rules and we'll solve some integrals with sines and cosines. Okay, at this point, I'm assuming you've already have the rules down. So it really just comes down to practice. The more you practice this, the more patterns you see, and the easier this becomes. Okay, so the very first example that I have for you is going to be this one right here. So we're going to integrate sine to the third power of x times cosine to the fourth power of x dx. Now, this is a little different than the type of trig you've encountered before, because in the past you were able to use u substitution, like selecting sine being u, you knew that the derivative was cosine. But because that cosine has a fourth power, u sub is no longer going to help us, and vice versa. Choosing u to be cosine, we have a derivative of negative sine, but because the sine has a power of 3, we're not able to use u substitution. That's the problem. Cool? So we're going to basically, you don't have this memorized yet, so you got to look up at your rules and see which one would apply in this scenario. So we've got, it says, if the power of sine is odd and positive, which with that, we have that going on, according to the suggestion of how to solve this problem, is to save one of your sine factors. So in other words, you've got to rewrite this. Instead of saying sine to the third power x, you are going to say sine to the power of x times sine squared to the sine square of x, times cosine to the fourth power of x dx. I'm going to show more steps than I usually would, just so that you understand what is happening. You're going to go back to use your trig identities from trigonometry, and this can be substituted by what? Okay, so we're going to make that substitution. We're going to have sine of x times 1 minus cosine square x times cosine to the fourth power x. And we're just going to multiply everything out. So now it's just algebra. Yes, so we've got the integral of what? We've got that times that gives you sine x cosine fourth power of x. And then that times that gives you minus sine x cosine to the power of 6x dx. And by doing so, what do you notice? Now u substitution comes into play. Okay? We can let u be what? Cosine. We definitely do not want to make u the sine. Yes, we want to make u the one with the power. Yes? So the one with the power on both of this is cosine, so we're going to let u be cosine. So u equals to cosine of x, which means that du is equal to what? Negative sine x dx. Now I don't have a negative with this one, so I'll fix this one in a second, but this one already has a negative, right? So I'll be able to take care of that, right? So what is the integral here? Well, if we use u substitution, I'm not going to show all the work. We know that this technically just became u to the fourth power, right? If I integrate that, that gives you u to the fifth over 5 with a negative up front because I need a negative. Agreed? So this right here becomes negative what? Cosine to the fifth power over 5. And then this one right here just became u to the sixth, right? Positive because it already has the negative in there. Agreed? So if we integrate that, what does that give us? U to the 7 over 7, which in this case would be cosine to the 7 over 7 plus c. And that would be the solution to our integral. Okay? So we're basically let's summarize what happened here. you're gonna use the rules above to rewrite it in a way that you can use substitution. That's really what's happening here. Cool. You're gonna use identities. You gotta find a way to use identities so that use substitution works. Cool. Questions about that? Yes, ma'am. Why did I pick the sine versus the cosine? Because that's a great question. So here's what happens. If you have an odd power, notice how the first rule and the second rule says that it's odd and positive. If you have an odd power and you keep one, that means that the remainder are going to be an even power. And trigonometric identities, the Pythagorean identities, are dealing with even powers. So that's why we're going to be able to rewrite it. That's the reason why I chose the sine, because the sine had an odd power. So keeping one of them will cause me to have an even power remaining factors, which I can then use Pythagorean identities to turn into cosines in this case. Oh, no. You just basically see which scenario applies. And sometimes there are going to be scenarios where multiple of them will apply. You just choose one and hope for the best, honestly. Cool? I mean, you honestly would not know where it's going to take you until you start actually working with it. Cool? All right, do we get the idea of what's happening? Yes? All right, let's try another one. So I'm going to let you try this on your own. So we're going to do a definite integral to make sure that we don't forget how to use our fundamental theorem of calculus. So we're going to do a definite integral from pi over 6 to pi over 3. And I'm going to throw a curveball your way, see if you guys can handle it. So cosine of the third power of x divided by the square root of sine of x dx. I will tell you that this is not going to turn out to be pretty, but I want you to give it a shot. You have the rules, okay? See which one of the rules apply, and then just proceed from there. Cool? So if you're watching the video, I'm going to go ahead and tell you to pause it, give it a try, and then when you're ready, hit play again. All right, I am assuming you've given it a go, so here's what I got. Let's talk about the calculus part of it, because the algebra was terrible, right? And honestly, I didn't even simplify. I would just left it wherever I put it here on the paper. But anyways, first, you should have recognized that we had an odd power of cosine, which meant you were supposed to keep one cosine and convert the other one to cosine squared in this case. Cosine squared is the same thing as 1 minus sine squared. Yes? So I can rewrite it. I kind of rewrote it this way. Maybe it helps you out. Yes, I'm going to keep that cosine by itself. I'm going to actually do the division here, 1 over that, and then sine square over that, which breaks up into those two expressions there. If you multiply in the cosine, then you can actually break it up into two separate integrals. You do not have to show that you broke it up into two integrals, but if you wanted to, you could. We're going to let u substitution here, and we're going to let u be sine. Yes? And you should be able, calculus-wise, to get that this was 2 square root of sine, or 2 sine to the 1/2. And the other part of it would have been negative 2/5 sine to the 5/2 power. Cool? And then this is a definite integral, so you were evaluating both of those from pi over 6 to pi over 3. I wouldn't take it any further than that, honestly. I'm not going to give you anything with this numbers that difficult on an exam. If I did, I would let you use the calculator to figure that out at that point. Cool? Yes, sir.
So when you brought the sine to the 1/2 x up, you multiplied the 1 minus sine squared x.
Right here.
Why is the minus sine x? Is it 2 over 2 or 1?
It's 3 over 2. So right here, so think about it. 1 over sine to the 1/2 x, you understand why it's sine to negative 1/2 x, right? But when you have sine divided by sine, because it's the same base, all you got to do is subtract the powers. So 2 minus 1/2 is 3/2. Cool? Any other questions? We're good? All right. Then let's move on to our next problem. So let's say that we have something like integral of cosine to the 4th power of x dx, completely by itself. Cool? All right, so this is where that third rule kind of comes in and helps you out. It says that if you have even powers, you are going to use the power reducing identities. Okay? First of all, what I would do if I were you is I would rewrite this in a manner that I had a cosine square. So in this case, that would be a cosine square x squared dx. Now this is where you want to be careful. I know that cosine square x can be replaced with 1 minus sine square x. Yes? And that you could square that. Agreed? But wouldn't that lead you to also having a sine squared? And then at that point, you're going to be like, well, let me replace that with cosine squared. And then you're going to find yourself in a loop and never going to answer the question. So the reason why I'm not replacing this with the Pythagorean identity is because I don't have a sine next to it. You with me? I only have cosines, which means that I have to use the power reducing identities. Cool? So the power reducing identity for cosine square, it is equal to 1 plus cosine 2x divided by 2 squared dx. And you will have to know those for the tests. Cool? So there's a power reducing. What do you suggest from here? Anybody? Something. What would you let u be? The 2x. Now we got to be careful about that. Are you saying that because then that 2 can kind of go away? You got to be careful because in technicality that's a 1/2. You see what I'm saying? So, but then even if we got rid of that, then our problem would still be that 1, and then that would still square. Cool? So I don't think u substitution would be the way to go here. I think you just forget calculus. I think you just need to go back to algebra. Like, what do you need to do? Like, not factor it out, but the opposite. Multiply it all out and see where it takes you. So we're going to go ahead and multiply everything out. So what do I have, or what do I get if I multiply 1 plus cosine 2x over 2 with itself? 1 plus 2 cosines 2x plus cosine squared 2x over 4 dx, right? Okay. But now what? Say that one more time. There's a couple things I can do. First, I can get rid of, well, not get rid of, but I can pull out a what? I can pull out a 1/4. Secondly, I can split this up into 3 different integrals. You don't have to, but I'm kind of just trying to show you, because 2 of these I'm ready to solve. One of them is the one that's giving me trouble. But I can separate this into 1/4 1 dx plus 1/4 integral 2 cosine 2x dx plus 1/4 integral of, what do I got, cosine squared 2x dx. Out of these 3 integrals, you can solve 2 now. The last one, we'll talk about it here in just a sec. Okay, so what is the integral of this? X, so it'll just be x over 4. Cool. I know it has a plus c, but we'll tackle the plus c at the end. Cool. What about this? Well, I can do u sub, where u is 2x, which means that du would be the 2. So in reality, all I have here is cosine of u, right? If I replace this with a du, right? So what is the integral of cosine of u? Sine of u, right? But I have a 1/4 outside, right? So it's going to be plus 1/4 sine of u, which in our case is 2x. Agreed? And lastly, I'll go ahead and rewrite it again, but how could we tackle that problem? Say that one more time. Good. You have a cosine square again. You're going to have to power reduce it again because I don't have a sine again. You with me? So I'm going to have to power reduce it. But here's the difference. At the beginning of the problem, we had a cosine square of x. Now we have a cosine square of 2x. Does that make a change to the power reducing formula. Because the power reducing says cosine square of x is